Okay, Bismillah ar-Rahman ar-Rahim. Let's start the second lecture in the course 240 Database Management Systems. Let me remind you what we have discussed last time very quickly. We have introduced the concepts of database management systems, and we have seen this picture before, that a database is centralized for the whole organization. Let me use the pointer here. So the database, all data are stored in a database that's centralized for the whole organization, managed by a database management system, which is a software. It's a piece of software. It's a program that we can buy from somewhere, from commercials, when we have seen many commercial systems available in the market. And then the programmers will do very simple programs that access the database using the DBMS. We have seen that the different views, the sales department view and the contracts view, by view I mean the need, the scope of data required by this department, are all integrated together into this single database. So we have seen that the sales department requires some of these files: property for rent, client, and the private owner, while the contracts department require some other set of data: the property for rent, the client, and the lease. So all of them have to access the same set of data. This guarantees no inconsistency because there is no duplication. In order to do that, the database management system will have to store the structure of the database. This structure is stored in what we call it the metadata, or the catalog, the data catalog. So the DBMS maintains or manages two pieces of data, two data storage: the database itself, where the data are stored, the student IDs, the student numbers, marks, and so on, and the structure of the data, the data about data. That's why we call it database, why we call it metadata. Again, also this picture gives us another idea about how DBMS works. So all applications should interact with the data or the data structure, the metadata, through the DBMS. But the DBMS also allows other users, some human users, not only applications, to access the database by providing an interface, a user interface. This interface will allow the user to communicate with the DBMS using specific languages, and we have called these languages data manipulation languages and data definition languages. So using these data, the human user can access the DBMS, asking for data, to retrieve data, or asking actually for information. So this saves time of developing new applications to have this kind of access to answer this type of queries. Also saves time of building or doing changes in the structure of the data if this is mandated by new changes in the environment. This is an example of the database. This is another example for how the metadata are stored. All of these have been discussed in last lecture. Let us go further and give some idea about the different other functions of a DBMS, database management system. Database management system, as we have seen, provides a mechanism, a way of storing data, retrieving data, and updating data. By update we mean insert, delete, and change values of some fields. Also, it allows the user to access the catalog, or actually in the beginning it allows to define this catalog by defining the data structure using the data definition language, and also it allows the user to access and maintain or change this catalog, the metadata, the database structure. But this is not the whole story. I mean, DBMS, professional DBMS can do much more than this. In fact, the first two points here, the first two functions here should be provided. This is the minimum that have to be provided by any DBMS, even simple ones, something like access. Some other functions, such as transaction support, are provided by DBMS. A database management system can do what we call it transaction support. What's a transaction? What does it mean, the word transaction? Transaction. What does it mean, transaction? Because you came late, we were talking about the functions of a DBMS. This is the first functions of a DBMS. We said that DBMS can, every DBMS, even the simplest one, Access, for example, Microsoft Access, should be able to store data, retrieve data, update data. Also, it should allow for accessing the catalog, the metadata. But what else? We're talking about what other functions a DBMS can support or can provide to the users. So the one more professional function that a DBMS can provide is the transaction support. So I'm asking, what is the meaning of transaction in that context?
The transaction of data, for example.
Yes, that's what I'm asking for. What is meant by transaction? Okay, I'll give you an example. A transaction means a change in the database. So this is an example. In a banking system, a customer wants to transfer money from his account to his friend's account, from account X to account Y, for example. Want to transfer money, 100 Riyal, for example. Okay, so this is the request. So one request is saying transfer 100 Riyal from account X to account Y. How this is implemented, how the DBMS is going to implement this, how the DBMS is going to respond to this query. Of course, the programmer should tell how to do the transfer. So it says what? It says withdraw money from account X, اسحب money, account X, and deposit that amount, withdraw 100 Riyal from account X, and deposit that same amount, 100 Riyal, into account Y. So to respond to the transfer request, we do two steps. Withdraw from one account, deposit in one account, in another account. That's what we call transaction. Of course, this transaction has to be done as a unit, has to be done as a whole. You cannot execute only one of them, only one part of it, and the other part is not executed. For example, after you withdraw the money from X account, the 100 Riyal from the X account is withdrawn. Now suppose that some time failure occurs. Some power failure, whatever the failure is, some failure has occurred. What would happen?
The operation would be cancelled.
The operation is not done properly. The money is withdrawn from the account, but it's not deposited in the other account. So the owner of the first account says, I did the transfer, but and the money is have been taken out of my account, but it's not reached there. It doesn't go to the other side. So there is something wrong happened in the overall transaction. So the DBMS has to be able to manage this. Has to, as you said, has to roll back. Roll back means go back to the time before, to the time or the state before the transaction begins. So return back the money to the X account. You got it? So this is as a whole. So the word transaction means that I need, the programmer would tell the DBMS, I need all of these actions to be done as a single unit. If failure occurred in the middle, then you have to roll back to a secured state to guarantee that the whole system is in a stable state. So this is done by the DBMS. The programmer doesn't have to do anything for this. The rollback is done automatically. All the programmer needs to tell the DBMS is this is a transaction. Starts here, ends here, and that's it. So it makes the programmer's life easier. He doesn't have to do lots of work. Concurrency control is another service or function that can be provided by professional DBMSs. What does it mean, concurrency control? What's concurrency? Concurrency means that, concurrency means that two things are happening at the same time, concurrent. They are done concurrently. And a simple example for this, in an ticket reservation, airplane ticket reservation. Two agents, two employees, doing ticketing, okay? Two customers, whether they are sitting aside besides each other or in different offices, different cities, wherever they are, we don't care. Two customers came asking for reserving a ticket from, say, he wants to go from Jeddah to Riyadh, for example, at this specific date, this specific time, this specific flight. So the first employee, first agent will query the system, is there a seat available? The system will respond, yes. The second agent for the second customer asks the same question and the system will respond at the same time or whatever, ask the same question and the system will respond, yes, there is one single seat available. So the agent one asks customer one, okay, there is one single seat, do you like to reserve it for you? Let me think, okay, and the same scenario is happening at the other side. Now, both decided at the same moment, both pressed the same, the reserve button, they press the button at the same time, and now there is a racing. Who comes first? So one of them will, the real scenario, what should happen is that you go and do the reservation for this agent one, for example, and it is done successfully for him. Now when the other request comes into the system, he should say no more seats available, right? But what happens if this is not properly controlled? This is what we mean by concurrency control. Although when the query is issued, it says there is a seat available. Why? Because at that moment there was a seat available. But because there is time lag between the query and the response, between the query and yes, I need to reserve the seat, this time lag, probably the seat has been reserved. So concurrency controls means that we need the response, these concurrent activities not to interfere, not to give the wrong effect. So I cannot reserve the same seat for both customers at the same time.
So like the transaction, it should be rolled back.
No, it's not roll back. It's not roll back. It is going to be refused, not roll back. Because I'm going to accept it. There is a difference between query. It's a query, yes, there is a seat available. But reserve it, sorry, the seat is no longer available. It's not roll back. Roll back because here there is a roll back because the transaction is done partly.
Partly, yes.
Part of it is done, so let us reverse that part. Do the opposite of that part in order to come back to the beginning, at the beginning time of the transaction. Yeah, before the transaction begins. Let's go back to the same status before the transaction begins. But here there is nothing happened. But the actual action, there is a big difference between reading and writing. We are talking about writing. So in reading, yes, no problem. Everybody can read concurrently. But when writing, we cannot write concurrently. Because this means that we are going to make the two reservations for the one single seat, which is not acceptable. So who can manage this, or who is responsible for managing this, is the DBMS. If DBMS is not there, then the programmer has to do it himself. In the program, has to do all the actions to guarantee that there is something called the critical section. No two programs get into the critical section and all of that. Yeah. This is a very important function if you are working with databases that are huge with many users working at the same time and doing updates at the same time. Recovery. Recovery means that, okay, we talked last time about the importance of data to any organization. And we said data is nowadays becoming secure. Recovery is something different than security. It's now becoming
security of loss.
Yeah, it's becoming an asset. It's an asset. The word asset means that it's worth money. It's worth based on the data. The database may collapse if something goes wrong with a database. The whole organization might collapse. Imagine that in this university, the student records have been lost. How can they? Who have graduated? Who have not? Who have taken this course? What are the marks? What are the grades? And so on. This is disaster. So the whole university might collapse because the loss of such a database, such part of a database. So data is very important to organizations. It's an asset. It's worth money. It's worth the life of the organization. So maintaining or guaranteeing that the data will not be destroyed or damaged or lost or whatever happened to it. So this is what we call it recovery. So recovery means if something wrong goes with the data, then we have to be able to recover, to bring the data back to as close as possible state before the damage. Okay? So this is what we call it. Who is responsible for doing that? Again, the DBMS. Of course, with personnel who are using facilities or tools provided by the DBMS to do the recovery. So the idea is not just taking backups, but also the DBMS takes logs. So everything happened to the DBMS, to the data, is logged. Logged means recorded. So when you insert a new record, it's recorded. Who did that? At which time? What is the data that are inserted? When you update a certain field, everything done to the database is recorded, is logged. Now using the log, some tools, we call it recovery tools, will help the DBA or the database administrator, the person who is taking care of the database, who is operating the database, will be able to recover the database to a closest state. It's not necessarily the last state, but at least the closest state. The loss of data will not be too big. It will be an acceptable margin. So all of these are very important functions that without it, we cannot guarantee that the data are properly maintained, are properly managed. But these functions are not necessarily available in all DBMSs, professional ones only. Access doesn't have, Microsoft Access doesn't have all of these functions except the first two. As I said, the first two are mandatory for all DBMS. This is the minimum a DBMS can have or must have. Authorization service. Let's continue on the functions. Authorization services. Is it acceptable that everybody can access the database and do whatever he wants with the data? Of course not. Example, student cannot change his marks. The dean cannot change the marks. Why? Because the marks, the one who is responsible for changing the marks is the instructor. The student cannot even view or see or retrieve data about his colleague. So all of this kind of stuff, the instructor can change the marks or change the marks for his students, but not for his colleagues' students, the other section, for example. So this means what? This means that data should be accessed in a managed manner. Who is authorized to do what? So the DBMS gives authorization, of course, a DBA, database administrator. We call it database administrator, the one who operates the database system. The DBA will say, Saad will be authorized to do this and that. He is able to insert a new record in here. He is able to retrieve this field or record. He is able to update this field and so on. So he gives Saad all the authorization. Of course, he will give him the username and password, assign him a username and password. So when Saad log into the system, log into the DBMS, log into a program or using a program that uses the DBMS or access the data, every time he's trying to access the database, the DBMS will see, are you authorized? If he's not authorized, the access will be denied. If he is authorized, the access will be accepted and go through. So this is managed by the DBMS in order to guarantee or to give more security to the system, to the data. Data is asset, as we said. So it's important to have controlled access to this data for proper use, and this adds to the security of the data. There are many others. We don't have to go through the whole list. These are the very important issues for our functions that a DBMS can support. Now let's move to another topic. Let's talk about the process of developing databases. How we develop database. What are the steps we go through? Before we do that, let us have some definitions. It's clear the words? Or? Okay. Let us have some definitions clear so that we can use them properly in our discussion. Many word. What's a many word? Many word means a small word. What's a small word? The many word is the part of the organization that we are going to build a database management system, a database for them. ManyWord is the part of the organization that we are going to model their data requirements and build a database system for them. Okay? Simply, as simple as that. Some part of the real world about which data is stored in a database, and here are some examples. ODIS, for example, is, what's the mini word for ODIS? The academic, the academic operation in the university, for example. What is the customer support in a banking application? It's only all the management of accounts, opening a new account, depositing, withdrawing, transfer, and so on. So this is the mini word we are focusing on. So by mini word we mean part of the organization. It is the scope we are working on. We are building database for it. Data, of course, is what? The word data is familiar to us. Data is what? We discussed data the first lecture. Yeah, but it is the facts to be recorded or stored in a database. So database is where to store the data. Data is those things, we need to store. And database is where to store them. Database management system, of course, it is the system, it is the software that manages these database. And we have database systems. I said a database system is a combination of database and database management system and all other software information system or whatever that handles these databases. So the DBMS software together with the data itself. Sometimes the applications are also included. So let us get these terminology straight. ManyWord, part of the word that we need to focus on when building our database systems. Database systems here. Data stored in a database which is managed by a DBMS. Knowing these, let us go and study or discuss what is the process of designing a database. The idea of designing a database system is the word model. Model. So we model data. We model the data requirements of the ManyWord. Build a model for these. So what's the word model mean? Okay, let me ask another question. What does software mean? What the word software? Software means what?
It's a code to operate a hardware, I think. The basic thing. Software. I think it's clear.
Yeah,
No,
okay. So let me ask the question another way. What is an information system?
It's a system
to provide information. About what? About a specific ManyWord, right?
Yes.
So in order to get this information about the ManyWord, what should we do? We should model the physical system, right? We see how the physical, what system analysis? Have you studied the software engineering 250? Right, okay. When we build a software and information system, we have to go to the ManyWord and
See what we want.
and imitate, understand how the operations work there, and then simulate these operations, imitate these operations, model these operations into a piece of code, into a software. So the software is a logical model for a physical system. We can simply say that. A software, an information system, is a logical model. It models what? Models a physical system, the ManyWord. Okay? So the idea of building a software, similarly, the idea of building a database is modeling something about the many world. When we talk about software systems, application systems, we talk about modeling the processes, the activities. When we are talking about database, we are modeling the data. So the word modeling here is very important in order to do our job. Actually, our job is modeling. It's trying to understand what are the data requirements of the many world. Try to see how to model this into into the technology of software, into the technology of computers. So converting the actual data format, into a format that could be stored in a computer. So this is the whole job. What is required, how they do their job, how do they use the data, what are the data needed, and how they use the data. And then, if I understand this, my job is how to do the same on the computer. So this transfer, this is called modeling. So we are modeling the data from one form into another. So in order to do this, we have to understand what is required, the data requirements, and then also we have to communicate this understanding to the different involved people, and then build our models. This is the process we want to discuss. So we go into a process like this of 4 stages. At least this is a simplification of the process that goes into 2 main phases: analysis and design. By analysis we mean understanding. By design means we are going to implement the model, build the model and implement the model. So the process starts by data collection. Data collection. What does it mean, data collection? I need to understand. This step is about understanding. The second step is about documenting my understanding. The third step is about transferring, or transforming this my understanding into a real system, into something that's implementable on a computer, and then implement it. The last step. Let us go deeply in each of them. Data collection means that you need to understand the data requirements of the many world. So you go, we have here 2 mechanisms, two ways of doing so. 2 tools to be able to collect the data, to build the understanding. First of all, interviews. I go meet with my clients, my users, the people who are actually doing the work in the organization, in the many world, and interview with them. Go and chat with them, discuss with them. What are you doing? How you do it? What type of data you need, and so on. The second tool to use is the forms. Of course, if you remember the first lecture, we said data are brought from the word data is the inputs, right? So where to get the inputs? How the user or whatever provide these inputs? It's a form. So you fill in form. We call it form. So collecting the forms that are used by the many world is a big important tool here. It's a tool that by analyzing, by studying, by understanding what are these forms about, what are types of data they store, they contain, I can build an idea what are the data used in this organization. Reports. What are reports? Reports means that you organize the data or the information actually retrieved. You take the data, produce information. Now this information to be presented, to be documented, right? So this is what we call it report. So you report the information. Give me a list of all students who got an A in this specific course. So I have to write down who are those students. Student ID, student name, what's the mark, and so on. So this is what we call it report. So out of the reports, we can infer what are the information they are requesting or using, right? So we forms to understand what are the data requirements, reports in order to know what are the types of information they request. Of course, this is not the whole picture, but we fill in, or we build the other parts of the picture using the interviews. So interviews are used for two things. First, to collect these forms and reports, to discuss them with the customers, to know the details of them, to understand them very carefully, and then also to complete the whole picture. If the forms and the reports are not sufficient, there are something else that's not included in those, I will get it from the users through the interviews. So data collection. We will go through all of these forms along our course, but let us in this picture just give me an highlight, an overview. So now, we collected the data. How to formulate this in something, in a form that's going to be converted into something to be stored on a database, to be stored on a computer. So I cannot store the data as it is, in papers, in forms. I cannot store it like this in a computer. So what we do is take this raw material, raw inputs, all of the collected data or understanding about the data requirements, all of these, I formulate them, summarize them, include them in what we call it the data model. So the first conceptual, we call it the conceptual data model. So this step is going to model this physical need of the data into a model. The word model is something logical, something that's not forms, papers, things like that. It's going to formulate it in a way that's integrated together. All departments, all data, all forms, everything is integrated in one model. We call it conceptual model, and I'll explain why conceptual in a minute. So we formulate it in a way that's easy to understand, easy to express, easy to represent everything about the data requirements of the mini world. We use a tool called the entity relationship diagram. So it's a diagram. So we are going to express our understanding of the data requirements that's collected by the fact finding here, the data collection here, into an ERD, into a diagram. Why it's called conceptual data model? It's a model. We agree that it's a model. It's a model for what? For data. So it's a data model. Why it's conceptual? It is conceptual because it abstractly specifies the data requirements. It doesn't care about how you are going to really implement it on the computer. Are you going to implement it using tables, using files, using whatever, using Oracle, using whatever database management system? I don't care. This is the data requirements. So this isolates the two views, the analysis view, the data requirements, and the design, how it is going to be implemented on the computer. Try to make them independent of each other. Why independent? This will give the designer, this person here is called data analyst, and the person doing this part is called data designer. So the designer will feel free to choose the proper implementation way, the proper data model, the proper DBMS. He is free to do his task without being enforced to do it in a specific way. That's why we insist that the data modeling at that stage is conceptual, on the level of the concept. What do we need from the data? Not how we are going to implement the data. What versus how. This is what we need. We don't care about how it is going to be implemented. Anyway, we will see examples in a few minutes. We use a tool, we use a language called ERD, Entity Relationship Diagram. It's a drawn language. It's a language that uses diagrams. Why diagrams? Because diagram, one picture is worth of 1,000 words, as the Chinese idiom says. One picture talks a lot, says lots of things, that when writing, even you will not be able to be accurate in writing it, accurate in understanding it. Words might not be as sometimes vague, sometimes mean something different to different people. So, but diagrams are accurate, clear, simple, and so on. So, this ERD, if you look at it is issued where? At the end of the data modeling step. So it is done by this step. And this step in the middle of what? In the middle of two other steps. The peoples involved in the two other steps at the two sides are different people. Here is what? The customer. Right? Here we meet with the customer. And we got this understanding from the customer, from the user. We got our understanding from the user. Do we understand him properly, accurately, completely, or not? We don't know, right? If I did not understand him properly, then I might implement something different than what he wants, and this is a disaster. After spending much time, more time, very long time, paying expenses of producing this software, and then when the user or the customer looks at the system and tries to work with it, it's not what I was expecting, right? So in order to guarantee that we understood our customers properly, his requirements properly, then we need to communicate our understanding to him. We need to discuss our understanding with him. We need to get his approval. Yes, this is the proper understanding. Yes, this is what I require. Right? On the other side, these documents, this understanding should be communicated also to the designer, who is going to take this understanding, these data requirements, and implement it or convert it into a design that's going to be implemented on the computer, right? So this person here, the data analyst, communicates with two different types of people: the user and the designer. And the two are of different background about database design, database programming, and so on. This person here knows nothing about, nothing professional. He's not professional. He's a user. He's very professional in his area. If he's an accountant, if he's banking, if he's whatever, he's very professional in his area. But he is not professional at all, or I'm not assuming that he has any level of proficiency in database and software development, right? While the other person here, the designer, is on the opposite side of the table. Well, he has probably has nothing to know about the area itself, yes, but he knows, he's professional in his industry, he's professional in software development and database. So they both speak different languages, right? This speaks software and database, and this speaks his specialization or area of specialization. But this man has to be able to speak both languages. So how can you speak both languages? How can you produce a documentation that specifies the data requirements, one single documentation that's understood by both who are not, both are not at the same level of background. They don't speak the same language. So how to solve this dilemma, the ERD is one of the tools. It's a simple tool. It's a simple language that expresses the data in a conceptual way. It is so simple that doesn't require professionals to understand. It's so simple that and comprehensive. It's so simple that doesn't require professional to understand. But it is also comprehensive that expresses everything about the data so that the designer can do his job and implement a database in a proper way. So it's a very interesting language that we are going to study. Now, expressing the requirements in a conceptual model, ERD, the designer will take this ERD and transform it into a logical design. By logical, the word logical in software industry means that you are converting it into something capable of digital. It's not necessarily digital, but at least in the technology, under the technology of software. So here it comes which data model you are going to use. By data model, we mean how you are going to structure your data. Here is the data required, the ERD. This is the data required. But how you are going to structure this data using the data structure theories and the methods and all of that we all have studied for computer and computer science, right? So what type of data structure you are going to use in order to organize this data into something that could be stored on a computer. So this is the job of who? The database designer. And this step is done in two steps. First is converting or transforming this conceptual model into a logical model, still on paper, some design. But before doing this, he has to decide which data model, which data structure he is going to choose in order to do this implementation. In fact, let me jump so many slides. We have, let me show you. Yeah. Here, we have so many structures that could be used to store data. Along history, we talked about file system, right?
Yes.
And moved from the filing system to the concepts of database. The first database designed was something called hierarchical data model. What's hierarchical data model? Then, before we go into this, let me give the whole picture. And then they found some limitations and difficulties in this hierarchical data model. So they moved to the network data model. The network data model. Again, some limitations, some complexities, and so on. So they moved to relational data model, and then to what we call it object-oriented data model, and so on. So this is historical. All I need you to know is just the names of these. You know that their relational data model is not the only model existing. We are going to focus on relational data model. This is the last, or it's of course there is more recent one which is the object-oriented, but relational is the relational data model is around for at least 20 years, 25 years, but it's surviving. It's still going to survive for many other years. Why? Because it's so simple, as we are going to discuss. It's so simple, so easy. People are familiar with before even start studying it. It is based on some mathematical background. So if it is based in computer science, if something based on mathematical background, then it is strong and rigid. So you have theories supporting it. And theories means power. You can use theories in order to develop other theories and so on. So it's very rich, very simple, very familiar to people. That's why it's becoming, it became very popular, very common. People like it, and I think it's going to survive for many years to go. To give an idea, for example, this is the network data model. In order to access, for example, the branch, you have to get the branch. This is how they are stored on the hard disk. So in order to know any data about John, for example, what is his salary, what's his position, he's a manager or not, and so on. In order to get John, you have to know where he is working, which branch he is working. So you cannot go directly to John. You go to the branch, and from the branch you go and search for the employees working in that branch until finding John. So this was difficult. Actually, same for the hierarchical data model. In fact, the difference between hierarchical and network is that hierarchical, yes, you have to, in order to get into an employee record, for example, you have to know the department, or the department where he, or the branch he works for, whatever. Yeah, you have to go. So you go here. This is the starting point. So of course, under this you can find others and so on. So in order to find any record down the hierarchy, you have to start from here. So lots of accesses and researches, and so it takes too much time. Not only time for search, but also the more complicated process of insertion. In order to insert a new record, you have to link the new employee. You have to link it to the branch. It's tough process. While this is how to implement it in relational database. So we are going to focus on relational database. Relational database is made of tables. Who of us is not familiar with a table? Tables, this is a table. This is another table. If you look at this, can you understand what's this table? Yes, of course. You say, yes, this is a table called branch. It has those fields, these columns, branch number, street, city, postcode. Now I know that B001 is a branch number which have this address, right? This is another table, another piece of data, staff. So it talks about staff. We have staff number, staff name, first name, last name, position, sex, date of birth, salary, and branch number. So now I know that John works for branch B05. What is the address of B05? You go here, and okay, this B05, I know the address, right? So when I ask you a question, how can you, what's the address where John works? So go and find John, and then go to the other table and find a branch address. I mean, every one of us, even before studying database, even before getting into the College of Computer or Computing, he have seen or have seen before in his life many tables, and he can read tables, he can understand what's the data in a table. So it's a very simple model. Compare this to the other two, the hierarchical and the network. You'll find this is very simple. It's understandable by even non-professional. That's why it's very popular, very common, and used in most commercial applications, commercial DBMSs now. So our focus in this course will be on relational data model. Back to our process. So we are going. So that the designer have to decide which of these data models is going to use. Of course, we are going to use relational data data model. So he is going to transform the conceptual data model, the ERD, translate it into set of tables. Relational, this is what we call it, relational scheme. This is the logical database, the logical model. So converting the conceptual data model into a logical data model, this is what we call it design. We are still on paper, right? We still drawing these tables on paper. So a logical database in our course we will use the relational database model, and the logical design will be called the relational database schema as a terminology. Okay. Now, till now we are still working on paper. We need to put that into computers. So if you remember, we have some languages to communicate this with the DBMS. So the first thing is to decide which DBMS we are moving to this step, right? So which DBMS we are going to use? Oracle, Informix, Access, which database management system you are going to use. So you buy it. You buy this DBMS, install it on your machine, and then use the data definition language, the language that's provided by the DBMS for the user to describe, to specify the data. So we are going to specify these tables to the DBMS using the data definition language, and now the schema, the database schema, is implemented on the computer and ready for using the other data manipulation language to insert records into the database, update records if you need, and then retrieve information from that database. So this is the process we are going to go through in order to develop our database systems. Again, fact finding. Go and understand what are the data requirements of a mini word. Formulate your understanding using an ERD, entity relationship diagram. This is what we call it conceptual model. It's independent of which data model you are going to use, hierarchical, network, relational, whatever. It's independent, as we will see. It's just a representation of what is required. Then convert it into a logical data model. We are going to use relational at that time. Relational model, that's why we call it the relational database schema. Now, take this design into the machine using the DBMS and the data definition language. Now everything is set. The database is ready to use, to insert data, manipulate the data, retrieve information, using the data manipulation language and the query language. So this is the process we are going to follow throughout our course. Next lecture, inshallah, we will start by this part and move on later on. Questions? Okay, let us finish here.